performed 3 supervised models like KNN and support vector machines and backpropagation neural networks. And here x-axis represents the false positive rate, which indicates how many healthy animals wrongly flagged as mastitis, and the y-axis represents true positive rate, which represents how many truly mastitic goats we are detecting as mastitic. And the dashed line in the middle, in the red dashed line in the middle, indicating that it is a random guessing. So we perform KNN, it is clearly separating the dairy healthy versus dairy mastitic. And the area under curve 0.82 means 82% is indicating that how well the model is separating between the two groups, especially dairy healthy as well as dairy mastitis, which is indicating that suppose if we randomly select one healthy animal and one randomly mastitic animal, this model is creating that it is clearly identifying this mastitic model is 82% of this time. And then coming to the precision recall analysis, the y-axis represents precision, which means how many animals flagged as mastitic are really mastitic. And then coming to the x-axis recall, how many truly mastitic animals we are correctly detecting. And this curve shows that this model is maintaining good precision over a wide recall range, indicating that there is stable identification of mastitis positive animals without excessive false positives. And this is especially important for on-farm screening tools because very many too many false alarms would reduce the trust on farmers. And then coming to the unsupervised structure, here we used combination of principal component analysis plus clustering. This graph is showing how the data is naturally grouping goats based on the electrical parameters without giving labels such as which goat is healthy and which goat is mastitic. Without giving labels, this data is naturally separating it is truly mastitic one or is healthy one. And then we use principal component analysis because we use dimensions such as resistance, reactance, and phase angles. And this principal component analysis is compressing all the complex data into simple data. And from this simple data, this k-means clustering is selecting and grouping those based on the similar points from where we already have different physiological parameters. However, mastitis develops gradually, we need superficial learning such as KNN and BBNN. And then coming to the longitudinal forecasting ARIMA, mastitis is not a static condition, it develops over time. So in autoregressive, in ARIMA, A stands for autoregressive, means today's values are always related to the past values, and I means integrated. It handles the changes by looking the changes over the period of time. And moving average, MA means moving average, which indicates the data should be measured repeatedly over time. What does this blue line indicate? This line indicates the observed phase angle value, and the spikes indicates physiological trends over the period of time. And the orange point in the end is indicating that ARIMA forecast predicted next value, which indicates that any future observations are deviating from the baseline predictions. We can detect this goat is going to have mastitis very soon. And we can say 95% confidence interval because if you repeat the same study so many times, the true curve is lying behind the base prediction values, making the trends stronger. And then coming to the survival analysis, to evaluate disease dynamics, we perform survival analysis using time to first dairy health to dairy mastitis transition. This curve, this Kaplan-Meier curve shows the probability of detection mastitis over the period of time. We observe a gradual decline in this graph is indicating that more animals are developing mastitis as time changes, as time moves on. Here the x-axis represents the days, which is indicating that we are watching goats when the mastitis appears, and the y-axis indicates that mastitis free survival, means the percentage of goats are healthy after mastitis. And then each step down is indicating when the goats are appeared for mastitis, when the goats are developing mastitis. And this indicates that high risk animals are exhibiting significantly shorter mastitis free interval. And then take home message, in summary, this method is lightweight, I can say, and scalable, and it does not hurt the animal. It can screen and monitor animals regularly, and this model is interpretable, and we can use directly on farms and can give early warnings before disease appearance. And this research helps most mastitis management from reacting after disease happens to predicting and preventing disease earlier. I want to acknowledge my major advisor, Dr. Thomas Terrell, and my mentor, Dr. Aftab Siddiqui, and my lab mates and my collaborators at Fort Valley State University and Queen's University, Belfast, and University of Pretoria. Thank you.